Hi everyone, so now we are gonna look at how we could generate the low resolution and high resolution PEEM image pairs with this PEEMVision software. So let's go to the remote server and then click to continue. Okay, so one thing you want to do every time you open the software is to use ROI for alignment. And then you could either go to file load or just like open this. Let's go to our directory, share drives, and our PEEM image processing. And right now all the PEEM data, raw ones are in the raw PEEM data. And for example, each of these photos represent like one experiment likely. And during one experiment, we took multiple images. Then each folder over here, essentially during the experiment, we will generate one PEEM image from all those right cyclically polarized image and right cyclically polarized image. We call it XAS images. So let's start with an example here. Okay, so say we go to file number 31, and as you will see here, usually we would take around 19, from 0 to 19 index, so 20 images total. And then in this case, usually we take 10 images first from 0 all the way to 9 with one of the polarity, circularly polarized polarity of the X-ray. And then the remaining 10 is done by right circularly polarized X-ray, for example, the opposite dichroism, or the opposite direction in terms of circularly polarized X-ray. So then with this kind of processing, we could directly get an average of the 9 images. So we probably have like an average of the left circularly polarized X-ray XAS, and then have a right circularly polarized X-ray XAS. Then we take the difference, and that gives us our magnetic contrast, the so-called PEEM images. All right, so now here, if we want to process here the high resolution images, if we have 19, let's go all the way to the bottom, 19, and some photos they have 40 images, so you want to keep a note. Maybe you make an Excel sheet while you're processing like one big photo, and like how many images you were actually using for the high resolution images. Right now, if we have 20, we use 20 images for the high resolution and 4 images for the low resolution. If you have 40, I believe you could do 40 images for high resolution and 8 images used for low resolution. Okay, so for the high resolution image, we go to 19, and then you go all the way, press shift, click. One thing to note is when we're processing, it's better to do it in the reverse order when you're selecting the images, just so that it works better for the software. Okay, and now let's open. Yeah, just double check you have this use ROI clicked. The reason we need it is that we could do alignment. By alignment, you usually pick some dust or some artifact. Yeah, usually it's dust when you're imaging on the substrate. Don't pick anything on top of the magnetic structure, because the magnetic signal would or the XAS contrast would change as we flip the polarity of the X-ray, so it doesn't make sense to use that as alignment. So we want some stationary non-magnetic object. Okay, so now we have aligned everything. Yeah, let me just redo it. Now we have aligned it, and we want to sort. We do 2 and 10 because 10 images each. We take 10 in one polarity and then 10 in the other polarity. So for 20 images, we do 2, 10, and if we have 4 images, we use 2, 2, block size of 2, and then if you do 40 images, you will do like 2, 20. All right, so now this is finished. We would explode the image. Then that gets us 2 images, each for one polarity. And next step is operations. You can just drag it, and if you're doing it in the window repeatedly, you don't need to go to Windows and operations every time. It will just stay here. Now we do divide. Okay, so here is our P images. One thing to note is that when we are doing the alignment, the image edge might not align perfectly, and that's why we need to also like remove the edges. Don't remove aggressively, but also don't be too conservative. Then that's not helpful. Yeah, we want to have as much data as possible for now, but also don't want to like trim in the edges too much, that it would affect the contrast. Now we do this, select the region, okay, click, and we go to edit and duplicate. So now we are getting like center region here, and what we'll do now is to sometimes like when you notice the contrast is kind of dark on one side and bright on the other in terms of substrate, this means that we might not be aligning the microscope fairly well. So in this software, there is a way we call Parabolic Flatten. You don't necessarily need to use it every time, but if you see like this obvious dark contrast on one side, see like intensity here, you put your cursor here, and the intensity showing up on the bottom left. Say this here is like 32K, okay, and here we have like 34K, here is 34K. So there's like there's some changes or gradient along this way. And if we do Parabolic Flatten, this does help. So see, here is like 32K, and here's about, okay, yeah, not that big a change, but it does look like more even on that side. But we also see that, yeah, from top to bottom in this example, it doesn't really have a very nice gradient. So here's like brighter and here's darker. For now, I think it works for us. You will now go to File and Save As. When you save it, you make sure that you keep the original name and remove the pound key number. And this is like our high resolution, and you save it as a JPEG, JPG file. So every folder, you go into one folder, you will save two files, one for high. Okay, now we look at how we can do low. To do low image, we need to pick, you need to like think about it, right? So we take 10 images for one polarity and 10 for the other. Then you want to take the first two images, or you take two images from the first 10, and you take two images from the other 10. And I will do is like, for me, I will pick the first two. Doesn't matter, you could even pick like 12, 13, and then 7, 8, as long as you pick two images from each group. And for me, I will pick 11. Okay, you click your mouse here and you do control click, keyboard control 10, and then 1 and 0. Okay, so that's saved. Oh, by the way, when we are saving those process images, you might also want to save a version with Tiff, not just JPEG. So we have two of them because Tiff has a higher Tiff is like lossless. So when we use it for future processing, we don't need to repeat this whole process again. Okay, so yeah, let me show you quickly. So similar process, we redo it. We first pick region. Oops, my bad. We pick this dust here, artifact. Not artifact, it's just physically a dust there, but not magnetic, very likely. We do a line. See 1, 2, 3, 4, it's done. Okay, it's not too bad. Straight line is good, it means the alignment goes fairly well. And now sort, but make sure if you're doing a low this time, you change the block size to 2. Okay, don't need to change anything here. We do average, sort. Okay, now next thing we do is explode. Okay, and then divide. And we try to remove the edges a little bit. Okay, and once you know the region you want, click. Yeah, so once we have high-low, you know that because we do this cropping, the high-low resolution images are not necessarily aligned. So the next thing we need to do is use our program to align these images, which we already have. So yeah, once you're done with this, you can jump into using the Python program to do this. All right, so once this is done, we duplicate, right? Duplicate, and since we did use the parabolic flatten for the other, you use it as well. Okay. Yeah, I would encourage you not to always use parabolic flatten. Let's keep it the way it is. But if you do think there's a sort of large contrast in terms of the brightness by comparing like the substrate, then you might do it. Although here I still don't think it's the best scenario for this example. You see, probably the beam is more focused here, and here we have like brighter, but here it's too dark. Usually this part we see is also should be like white. Yeah, but this is something we'll address later in other processing. Now we have cropped it and duplicate, we would go and save as. Again, we save as oh, I already have this, but make sure you pick the right type. Pick JPEG, and because this is low, right? Just did a low, so change it to low and save it here. Okay, so that's about it. And every once in a while you need to, when there are too many of the files, it could make the software pretty slow, so you just close all. All right, so once this is done, you already have like two images, one pair for each of the folder. So let's just take a quick look at the images we processed. Well, let's see, right here. And I remember it was 31. So you might want to like keep a text file or like Excel file, and then you notice like you keep note of the file names. Look, so here, let's go to 31. Here. And I believe we have one low and one high. Okay, so I noticed that this is not working yet. Okay, so if we save as P3B file, it didn't really work. Let's try it again. So you can still open it from the software, but this time when you do JPEG, I think we want to also do like JPEG this way, just to make sure it's being saved. Okay, yeah, we have to do like .jpeg manually for it to actually save the file. Besides doing a JPEG, yeah, I would encourage you to like save the original file once you process high or low in P3B format, so you cannot really directly open it, so that in the future when you want to look at it in this software, you could just like directly open and then process it further. So every time you have a low high, you save as a JPEG file. You also want to save it as a Tiff. Save as TIF. I have to type it here for some reason. Oh, doesn't work. .tiff. Until you see it show up in this folder. See, Tiff is comparably lossless to JPEG, and then we have a bigger file size. So for like future training later, we hope to feed this file in our network, but for now we're going to use our JPEG. If you open it up, that's how it looks like. For TIFF files, when they save, they kind of like flip it by diagonal, so you might see it flipped compared to what we are seeing in the software. Okay, now I just want to finish this file quickly. We also want to make sure we have this high resolution image in P3B format, and we will also save as the JPEG. Yeah, once you do it a few times, you'll be like doing a streamline, so it'll be quicker, hopefully. Okay, save as. Hard for me to talk and do it at the same time. So yeah, here we go. Tiff. Save and then save as JPEG 2. Okay, so you do 3 types of format for each of the files: one P3B, one JPEG, one TIFF. And make sure you always type the .jpeg or TIFF file once you select the file type. So you have to select save as type and then put this this postfix here. If you do it here and then you select the file type, this thing just go away. Kind of weird for the software. Just keep that in mind. All right. In the meantime, I would suggest you to keep this folder open. If you have like Google Drive for a desktop, then it's better for you to see it in real time, how things are changing. So now you know, okay, I do have all the files here. And you will keep a note on the side that what folder is this, the folder name, right? And low, high, how many images you used. So for this, we used 4 images for low and 20 images for high. Okay, so once this is done, you could also go to like another file. See here, this kind of sample we took, I think we took 40. Yeah, we took 40 of them, from 0 to 39. That was because those features are fairly small and we are zooming in a lot. And to get high resolution images, we tend to take like more repeats of the images. So now I think that you're in a block of 20, block size of 2 and block size of, yeah, block elements 2 and then block size is 20. Now let's just do this as an example. Okay. What number is this? This is 34. Yeah. Okay, so here we select 39 all the way to this. I won't be talking, I'm just gonna show it so you can follow if you want to see. Well, this is kind of bad, but yeah, they are very small, so it's hard. But we do want to have different type of samples. So see this black thing here? It's actually like dust. So let's see if this one will work for us to do alignment. Yeah, see, it's kind of slow here, but it's progressing. Okay. Yeah, the alignment didn't go that well, but let's see how it goes. Yeah, if you want to redo it, you just like re-import all the files and repeat. Okay. So now our block size is 20. Yeah, when we are taking the PEEM images, we do zoom in a lot, especially for those smaller features. So you see the resolution also gets lower, and also the signal, if it's kind of weak from the magnetic component, then it didn't really show up clearly. Now, once we align, we did sort, right? We did sort, and then the next step is explode. We got 2 images, and then we divide them. See, when we have some alignment happening and now the side is black, it means that we have some like drastic movement during some movement. So if you wanted to recover the real contrast, you want to leave the side out. Okay. And now we go to edit and duplicate. Yep, so here is a better version of the high resolution images. Somehow I see this kind of structures look like they are a little bit shifted, so you have this kind of 3D artifact. So I think you could try again to see whether this is really the artifact due to alignment, right? Or it's because just how the sample looks like. For now you can save it, and if it gets better you override it. Okay. The way you do it is first you go to save as a Tiff file, and we know it's I'll just write 40 high, so we kind of know it's 40 images to get high, and dot Tiff. I also want to save it as a P3B file, and that is a JPEG version. Save as type first, and then the file name we appended. Alright, so in the meantime we can check here. Let me get a P3B. Let me do it again. Alright, showed up here. So yeah, one image, 3 of them. I just want to see if we can get better. Okay, what you would do is, let's try it. And maybe pick a different location for the alignment. Yeah, we want to try our best to generate the low and high resolution pairs as good as we could, so it's better for our later model training. Two and 20. See, if we do the alignment slightly differently by picking a different, actually this is a good dust to pick next time, and then you will get like sort of different results. So it means that alignment needs to be perfect, or perfectionist. Yeah, I don't know. Anyway, so sort is done, right? And we explode. Cool. And then you have divide. I think this might be better. Again, we go to the center. Make sure you don't get the edge too much. See, this one does look better. Earlier, like the version we had, it's showing some glow and some 3D effect, and this usually is not because of the these are usually like due to the alignment, because when you look at magnetic images, they should not show any topographical effect, so it should not be showing, oh, there's a 3D like structure. So this is better, much better than what we had, and I would actually replace what we have earlier. Save as P3B first, and then we had the Tiff, and now we want a JPEG. Alright, so they should all be here right now. Yep, this is what we wanted. And to generate the low resolution one, we mentioned we want to keep the proportion right. So 20 versus 4, 5 versus 1, so 40 versus 8. Then we load we'll pick four images from like the last 20 of them, and then 4 from the first 20 of them. Control, make sure, control, now 8 images in reverse order. And we mentioned that this is a dust we saw earlier. So I'm gonna use this guy here to do the alignment this time. Not too much on the edge. Yes. Maybe some shifting would. So some shifting of the images maybe implies later we don't even have this part in some of the images. So align, see how it goes. All right, we'll see. Sort. Block size is 4 this time. Yeah, you want to like write on your notebook which folder and how many images we're going to low and how many go to high. Okay, so that's done. We explode and divide. Add a duplicate. Okay, so those are our low resolution images, you see. And we will save as, yeah, so that's how it goes. And we will go through all these quickly in a team effort. Hopefully we can progress faster. This is not 4 this time, this is 8. As a matter of fact, I would think let's not put 8 and 40 here, but just write it in a document. I'm hoping we keep the prefix the same and just changing like low and high. So when we're doing the programming, it will be easier, you know, for us to do the naming. Got me? Okay, so let's try to rename without this. Similarly, so now they look the same, just that the postfix is different. Similarly, we save as this time it's low and Tiff. Low Tiff. Oh, I think it crashed. Wow, it's fine. Yeah, so the idea is like this, okay? Let me know if you have any questions.